In this video, part of a series of 2, we're going to talk about quality. How can we assess the quality of process models? How can we assure the quality of process models? And what is necessary to get a good quality process model? In order to answer that, we first need to look at what are models, or what do they consist of? And then there are 3 main elements that we need in order to go from nothing to a process model. First of all, we need the syntax. And the syntax are the elements of the process modeling language and the rules by which we can connect them. So if we look at chess, then the syntax are the different pieces and kind of how they relate to one another. The semantics are the meaning of the elements of the language. So the semantics denote what we need to know in order to interpret the model. So for chess, this would be that a horse can jump 1 forward, 1 sidewards, and 1 forward again in any direction in order to make a move. Finally, we need notation. So these first 2 are kind of abstract concepts where we don't really have any way to write them down or to represent them. And the notation tells us what it actually looks like in practice. So for chess, well, on the first picture here, we already have an example of kind of basic types. But here below, we see a picture of more exotically looking chess pieces. And these chess pieces have the same syntax, the same semantics, but a different notation. In process models, we have these 3 elements as well. So we have the syntax, and for our BPMN language, this can be gateways or sequence flows, just to name 2 examples. And the rules to connect them are that you can connect sequence flows to gateways and tasks, but you cannot connect gateways to tasks directly. You need sequence flows. The semantics tell us what these things actually mean. So gateways represent changes in the flow of the process, while the sequence flows denote the order of execution and kind of transport tokens from one place to the next. Then we have notation, where these elements that we had, gateways and sequence flows, have a particular way of writing them down. So for the gateways, we use these little diamond shapes, and for sequence flows, we use these arrows. These are the 3 kind of ingredients that we need in order to talk about models, and hence model quality. Why would we be so bothered with model quality, right? So process models is kind of a communication tool. So, if I get my message across, then why is that not enough to be a process model? Well, and for that, I would like to draw a parallel with languages, with normal, everyday languages, German, English, Dutch. If you look at this sentence on the slide, me wish to draw a parallel with languages, there are a lot of things wrong with this sentence. Not just the words, the grammar and the typography. There is a capital in the middle of the sentence. Can you still get the meaning of this sentence? Well, yes, right? If you read it kind of with your eyes half closed, or if you're a little bit drunk, then you will be able to understand this. But if I put this sentence into a report that I wrote as a consultant to my client, they're not gonna take me seriously, right? So it's not that you cannot understand what I'm trying to convey, but it's just hard to take it serious. There must be a bit of decorum around it. So that's why we need to take the quality of process models into account. We have a framework for process model quality. So it's not just, is this a model, do we like it? But there are a few steps that we need to take in order to say, yes, this is a good model. First of all is the structural correctness, which deals with, does it adhere to the language of BPMN? Second, is it behaviorally correct? Are there no rare cases or side issues that might screw up behavior? These two together we refer to as syntactical correctness. Next to that, we have semantic correctness, which tells us that the model expresses the meaning that we want to. These three together, so structural correctness, behavioral correctness, and semantic correctness, together we refer to them as correctness. So a model is correct if it has these three properties. Next to that, there are modeling conventions that tell you what the model should look like and maybe simplify it for the intended purpose. First one, structural correctness. For structural correctness, we want to ensure that the model adheres to the BPMN standard. There is a large document online, the BPMN standard, that tells you exactly what is allowed and what not, but I'm just going to give a few examples here. For instance, arcs must connect nodes. You cannot have dangling arcs and you cannot have nodes connecting nodes. There are also some element-specific rules. So for instance, if there is a start event, then there must be an end event in your model. That is in the BPMN standard. Start events must not have incoming sequence flows. And if you think about this kind of makes sense, right? So the start part of your model, the element that starts your process, you cannot put a token in there yourself because, you're not allowed to start it yourself. Once you start it, you're running. Similarly, for the end events must not have outgoing sequence flows. So whenever a token reaches an end event, it is there and it signals to the environment, so kind of the thing that is calling the process, hey, we're done. It doesn't make sense to signal to the environment, this process is done, and then remove the token and do something else. Then you are not done. Gateways must be proper gateways and not so-called trivial gateways. So gateways must be either a join or a split. Can be both, but if it's neither, with just one incoming and one outgoing sequence flow, then why bother with a gateway? Sequence flows coming out of an XOR gateway must have a condition or be default. So that also makes sense because if we say we have a decision to be made on data and you don't specify this data, then what are you going to do to execute it? There are heaps more, and please have a look in the BPMN standard for some of these element-specific rules. Here's an example. Can we find things that are against the BPMN standard in this process model? Well, yes. We have one here, which is a trivial gateway because it has one incoming sequence flow, one outgoing sequence flow, and there should be either more in or more outgoing sequence flows. We have a dangling sequence flow. The sequence flow doesn't go anywhere, and that's not allowed by the BPMN standard. Here again, we have a trivial gateway, and here we have a triangle that doesn't appear at all in the BPMN standard. These are some examples of violations of the BPMN standard. But let's have a look at why we would like to have that adherence to the BPMN standard and how to assure that. A computer cannot interpret a model if it doesn't follow the specification exactly. And most of you have programmed. So if you have programmed and you know that if you have a compile error in your code, then it's not going to work. The computer cannot guess what you meant because you didn't adhere to the standard. The same holds for process models. If we want to do automated analysis on these models, a computer has to be able to read it. Hence, you must adhere to the standard perfectly. So how can computers be used to assure the quality of a model for structural correctness? Well, Dedicated modeling tools might help you. If you draw your BPMN model in Paint or Visio or in draw.io or in Apple Pages, then you're not getting much support, so the whole burden of syntax checking is on your own shoulders. If you use a dedicated modeling tool like Camunda or Signavio, they have built-in syntax checkers. So by far the most rules that the BPMN standard have are already included in these tools, and these tools will warn you or give an error if you try to model something that is against the standard. There are also dedicated syntax checkers, so apart from the modeling tools, you can also apply a syntax checker. For instance, if somebody checks in a model in a repository, you can run syntax checkers to see if there are no errors in there. And computers can do this perfectly, much better than humans. For people, if the model doesn't adhere to the BPMN standard fully, besides of the parallel with textual correctness that I've shown you earlier, it's not such a big deal. I mean, you make a fool of yourself, maybe for very small errors, it's more natural, but people can still read the model, right? So they still can get the ID. But that doesn't mean that it's still a good idea to hand in models that don't adhere to the BPMN standard, even if you're not doing automated analysis, because it might be multi-interpretable and therefore your model might be ambiguous. How to assure the quality using people? Well, you can do manual checks, and well, as a teacher, you get quite good at that. But in the end, it's just a tedious job. It's much better to do this in a computer-based tool, but yeah, handwritten exams. That wraps up structural correctness. Next, we're going to talk about behavioral correctness. It is not enough that a model adheres to the BPMN standard. And let me show you why. Specifically for data-based gateways, such as the OR split and the XOR split, the data must be available. Imagine that you come at a point in the model and you have to decide between going left or right, and the model tells you that that decision is based on a data variable and that data variable isn't set yet. You're stuck, you cannot proceed. So this can never happen. This is forbidden according to behavioral correctness. Next, for an XOR split, at most one outgoing condition must be true. So in this XOR split, when you reach it, based on data, you should go either way. If you can go both ways according to the data, then your model is non-deterministic, and that's not what we want. In reality, we cannot have that because our execution engine must take a decision at that point. So not only data must be available, but there must be one option to go for. Last, if there is a default, then always one option is enabled. But you have to make sure that if there is no default, that at least one of the outcome conditions is true for XOR and OR. Again, if this doesn't hold, then you can get stuck in a split node, and that's not supposed to happen. The BPMN language doesn't have anything to deal with that. This is a situation you need to avoid in terms of modeling. So then more general notions for behavioral correctness. First of all, the option to complete. And that means that wherever you go in your model when you execute it, there is always a way to go to the end and finish the process instance. That means no deadlocks or live locks. There is the no dead activities rule for behavioral correctness. That means that it must be possible to execute every activity within your model. Now these three, they are kind of, you can kind of argue whether you want them or not. But just imagine what kind of issues you would get to in real life if you would have issues like this in your model. You would have customers getting stuck, or even worse, customers being referred to in live logs, or no dead activities. You have an activity in your model that takes effort in the organization. You know, it must be designed, people must be trained, IT support, but in fact, it can never happen. What a waste. So these three things we don't want to see in any process model. Let's look at a few examples. In this model, the option to complete is violated. And we can see that by simply playing the token game. If we put a token at the beginning, then let's say that the condition X holds and we go up. Then we execute A, and when A is finished, the token waits before the concurrent join. The concurrent join will wait for a token coming from the other branch, which is the branch coming from B. However, there is no more token here that can come. So, yeah, we are stuck in this situation. This is a deadlock. There is a token here, but we can never proceed until the end. This is a deadlock. Formally, we reason that we can get stuck in this process model. Hence, there is not always an option to complete. So there is a way to get stuck. Hence, the model violates the option to complete property. Another example. In this model, let's again play the token game. Let's say that X doesn't hold and we go down. The XOR join just forwards the token, we execute A. When we are done, then the XOR join just forwards the token, we execute A, and so on and so on. So this is a live log. So we keep this token here within this little circle, and we are never going to finish. So this is a live log. The process can get stuck, where stuck means that you cannot progress anymore towards an end state. There's not always an option to complete, because this process can actually finish by, in the first decision going straight, you finish without issue. But if you go down, you get in a live log, hence you cannot always complete. This model violates the option to complete property. And getting back to practice, both of these examples are bad, because in the top one we have a deadlock. Everything after the concurrent join will simply never be executed, so your process will get stuck. In the bottom process, if we go down in this OR split, then we will also never finish, and in fact we will keep on repeating A. Well, just imagine any task that you would want to have repeated forever. That's not something you want in a business process. So we don't want these types of issues in our model. Let's look at no dead activities. And let's play the token game to see which activity here is dead and why. We have a token, and let's say that, again, condition X holds. We execute A and then end up before the parallel split. The parallel split splits the token in two, and one token ends up before the AND join, and the other one goes towards the XOR join. The XOR join is forwarded and put into the AND event. Notice that apart from being in a deadlock, we cannot execute C, because this parallel join has only one token and needs two to proceed. So we cannot execute C in this way. Now, we do need further analysis to show that also if we go via B, we end up in a symmetrical situation with a token on the bottom. We can still not execute C. So the reasoning here is, The activity C cannot be executed. In no way can we reach activity C. Hence, the model violates the no dead activities property. And again, thinking from practice, this is bad. C might be some activity that we put in the process for a reason, right? I mean, we didn't put it there just for fun. So this activity is there, takes up resources one way or the other, at least people thinking about it, hence time, hence money. But we cannot execute it. According to this model, if we start running this process model, C will never be executed. So how can we assure the quality? And within that, first step is, why do we even need to assure the quality? For computers, again, models with such issues are bad. The computer can read it, but the issues that are there, for instance, a deadlock, will just propagate to any other technique that you apply. So if your model has a deadlock, then any analysis technique will also get stuck on that, or a live lock will never finish, and a computer might be running and not be able to perform its analysis. How can we assure the quality of the model? That's a bit tricky. There are model checking tools that can verify for the absence of deadlocks, but there is a slight issue here. BPMN semantics are informal. If you look in the BPMN standard, the way the semantics are described of the tokens and the elements and their behavior, it is informal, it is text. And that means that someone needs to make a translation from this informal text language to a mathematical formula that a computer can understand in order to do any type of model checking. This has been done for the basic elements, so it is possible to do model checking. But if you go really exotic on your elements, then you might end up with issues. Also think of the OR join. If you connect them in two ways, then we've seen in a previous video that gives paradoxes where you can prove that true equals false. Of course, computers will get hopelessly lost with that. Finally, for computers, BPMN is a Turing-complete language, including all the data. So that means that it comes with all the kind of nice undecidability problems, such as the halting problem. That means, in practice, that if you have a BPMN model fully specified with data, there is, in some cases, no way to compute automatically if you can reach the end state. For people, if the behavioral correctness is violated, so you have some issues in your model, you can still get the ID, but it gets already a bit trickier than with syntax, because imagine the deadlock we saw earlier, like we cannot proceed in the process. What does that mean? Do we have to kind of, think that it doesn't exist? Do we have to imagine that problem isn't there and how to fix it? You can get the idea, but again, you might get a lot of ambiguous issues there. So how to assure the behavioral quality of a model and to show that it is behaviorally correct is reasoning according to the text of the BPMN standard and your model, and using kind of experience and quick, almost mental proofs or hand-wavy proofs in order to show that your model doesn't have deadlocks and live locks. This wraps up structural correctness and behavioral correctness, and together we refer to them as syntactical correctness. And to wrap up this video, look at an example of a process model and identify syntactical correctness issues. In this model, there are a couple of syntactical issues. First of all, here on the left, we see an activity without incoming sequence flow. Now, this is fine, except if you have a start or end event in your model, and we have both. So this is a violation of the BPMN standard. A structural correctness issue. Second, we see that this OR split has a corresponding AND join. Now, why is this a problem? The OR can behave as either an XOR or an AND, so it can choose any or both of its outgoing sequence flows to produce a token. That means that it is possible that it produces one token that traverses F11 and then ends up for this parallel join. The parallel join will need two tokens, and there is never going to be a second one, so this is a deadlock. Next up is the event next to it, this one. This event is a start event because it has a single non-tick border. However, a BPMN start event cannot have incoming sequence flows. So this must be transformed in either an intermediate event or into a start event without incoming sequence flows. Next, here we have a so-called trivial gateway. A trivial gateway has only one incoming sequence flow and one outgoing sequence flow. So it doesn't control the flow of tokens at all. It's trivial. It shouldn't be there. So that's a structural correctness issue. Finally, here at the end, we have the symmetrical case from the structural correctness issue that we started with, and that is, if your model has a start and end event, then there cannot be model elements that do not have outgoing sequence flows, except for these end events. This wraps up syntactical correctness. In part 2 of this video, we're going to have a look at semantic correctness and model conventions.